In this session, I will discuss the results of aircraft wing analysis. Let's start the result analysis. For that, go to simulation runs, click on run, then click on post-process results. In parts color, select coloring as pressure. This is the pressure counter plot of the aircraft wing. As we know, the air flows from the leading edge to the trailing edge of the wing. When the air strikes the leading edge, the velocity of the air decreases and pressure increases. As you can see, the leading edge of the wing is represented by red color. At the leading edge, you can see the leading edge is represented by a red color, which shows that the pressure at the leading edge of the wing is high. We can also inspect the value of pressure at any point on the surface of the wing. That, go to inspect point and click at any point on the surface of the wing to inspect the value of pressure at that point. So at this point, the pressure value is 9.845 e to the power 4 Pascal. At any point, you can click and inspect the value at any point on the surface of the wing. The coefficient of pressure starts accelerating at the leading edge of the wing. This pressure is divided into two parts, that is positive pressure coefficient at the lower surface of the wing and negative pressure coefficient at the upper surface of the wing. Due to this negative pressure coefficient or low pressure at the upper surface of the wing, suction force produces at the upper surface. This suction force causes the flow on the upper surface of the wing to increase and also to increase the lift coefficient. As we know from Bernoulli's principle, the pressure on the upper surface of the wing is less compared to the lower surface of the wing. Let's inspect the value of pressure at the upper surface of the wing. So at this point, the pressure is 9.713 e to the power 4 Pascal. Here it's 9.723 e power 4 Pascal. In this way, you can see at each point on the surface of the upper surface of the wing what is the pressure. Here we can notice that near the leading edge on the upper surface of the wing we have blue color. This indicates that it is having very low pressure at the upper surface of the wing, that too near the leading edge. This low pressure results in suction force which increases the air flow over the upper surface of the wing. So at the upper surface of the wing, the pressure value is 9.713 e to the power 4 Pascal. Let's see at the lower surface what is the pressure. So this is the lower surface of the wing. At the lower surface, as you can see, the pressure value is more, that is 9.763 e to the power 4 Pascal. So at the lower surface of the wing, the pressure is high. than the upper surface of the wing. Next, to analyze the velocity magnitude plot, add cutting plane. Disable parts color. This is the velocity magnitude counter plot of the aircraft wing. At the leading edge of an airfoil, the velocity is 0. That point is defined as stagnation point. You can see the velocity magnitude is 0 near the leading edge of the airfoil. So this point is defined as stagnation point, which occurs near the leading edge of an airfoil. For incompressible flow, at the leading edge, the pressure coefficient is equal to 1. Due to negative pressure coefficient resulting in suction force on the upper surface of the airfoil causes the air to flow with high velocity on the upper surface compared to the lower surface of the airfoil. Here you can see the velocity magnitude on the upper surface of the airfoil is 42.37 meter per second, and the velocity magnitude at the lower surface of the airfoil is less, that is 41.64 meter per second. We can also see the velocity magnitude is high at the boundaries of the leading edge of the airfoil. Here it's 38.39 meter per second, and at the trailing edge the velocity magnitude is less, that is 30.81 meter per second. Next, to analyze the streamline flow over the surface of the wing, add streamlines. For that, go to particle trace, disable cutting plane, hide the domain, select translucent surfaces with wireframe, click here. You can change the horizontal vertical seats and spacing and size here. in particle trace, hide the domain. In parts color, select solid color and select surfaces with wireframe. Here you can see the streamlines flowing over the upper surface and the lower surface of the wing. You can also animate the streamlines flowing over the surface of the wing. For that, go to animation, select particle trace. You can increase the steps and animation speed and play. Next, to analyze the values of lift and drag forces, lift coefficient and drag coefficient, go to force plot, go to forces and movement. Here the pressure force X is the drag force and pressure force Y is the lift force. Apart from those two, disable the other options. Pressure force Y, that is lift force, is 182.018 Newton and the drag force or the pressure force X is 14.2929 Newton. In this way, you can analyze the values of your lift and drag forces. To analyze the values of lift coefficient and drag coefficient, go to force coefficient plots, forces and movement coefficients. Disable the other options, and here let's see what is the lift coefficient. So the lift coefficient is 0.1892 and the drag coefficient of the aircraft wing is 0.01639. Here, by dividing the lift coefficient value with the drag coefficient will give you lift to drag ratio of the wing geometry as 11.549. This completes the result analysis of aircraft wing. With this, I will end up this session here. Thank you.